So the question was asked, why is it that functions tend to go up or down as they get closer to their asymptotes? So let me explain. Now for this problem here, can we agree that if we set the denominator equal to 0, we see that our vertical asymptote is at x equals 3. So if I go to 3, there will be our vertical asymptote. Let's make it like this. And because the bottom has a larger degree than the top, we also have a horizontal asymptote at y equals 0, aka the x-axis. But for the purposes of this video, we'll only focus on the vertical asymptote and why the picture gets drawn upwards and downwards as we get closer to it. So if you go to Desmos, you'll see that the graph of this, it looks like this orange right here. This is the graph of function f of x here in orange. So let's explain why is it the case that as I get closer to this vertical asymptote, that this portion of the graph just spikes upwards. Here is the explanation. So where is the vertical asymptote? The vertical asymptote in this case is at 3. Let's pick a number that's like close to 3. How about the number 3.1? Let me take the number 3.1 and plug it into the original function and watch what happens. This becomes 7 over 3.1 minus 3, which is 7 over 0.1, which becomes 70. So the point on this graph from this observation would be 3.1 comma 70. Let's try this again, a different number. So 3.1 comma 70, that's 70 is pretty big. But you know what I want to do now? I want to get closer to 3 than 3.1. What is the number that's closer to 3 than 3.1? How about 3.01? Okay, this gives us, if I plug this in, 7 over 3.01 minus 3, which is 7 over 0.01, which is 700. And that point would be 3.01 comma 700. So you see what's happening. What's happening is 3.1 and then 3.01. This one had a y coordinate of 70, which is pretty high, but this one's way higher. So the point is, the observation is, as your x value, as your x coordinate gets closer to the vertical asymptote, the y coordinate gets bigger. And the y coordinate gets bigger for this reason. You see, as you get closer to, in this case, 3, if you go 3.1 minus 3, the difference is 0.1. Here, the difference is 0.01. A smaller denominator gives us a bigger quotient. I'll say it again. A smaller denominator gives us a bigger quotient. And a smaller denominator is created the closer and closer and closer and closer you get to the actual vertical asymptote value itself, which is why the graph gets pulled upwards as you get closer to 3 from this direction. And the reason that we go down from this case is for the exact same reason, but you would have negatives in the denominator. So that's why functions get pulled upwards and downwards as you get closer to an asymptote, because as you get closer to asymptotes, you're creating smaller and smaller and smaller denominators, which give us bigger and bigger and bigger y values.